So yeah, I'm Peter Tracey, a Caucasian male, mid-20s, medium-length brown hair, beard, wearing glasses, and a check burgundy shirt. Okay, so yeah, welcome. Thank you, organizers, for organizing and attendees for attending. This is my short presentation on cold reading chatbot for accessible PGD relief. My co-supervisor Chris Hughes is here to hopefully see me do well. My email's there, but I'll put it back up at the end if you want to contact me. So the first question you probably got is, what is PGD? Why do people need relief? PGD stands for prolonged grief disorder. We define prolonged grief separate from regular grief as when someone has difficulty processing grief, and that can be defined as when their grief period exceeds 6, maybe even 12 months. So if someone's still feeling the symptoms of grief after that time, we diagnose it as prolonged grief disorder. To give you an idea of the scope and the scale of this issue, this disorder occurs in roughly 10% of all bereavements. This is in adults and children, so 10% of all bereavements result in prolonged grief disorder. When we're talking about difficulty processing grief, we need to understand how do people process grief successfully. And we used to think of grief as being 7 stages. Many people might still think that's the case, but actually we now understand grief to be a successful processing of grief to be the successful accomplishment of 4 grief tasks. These tasks are, in no particular order, by the way, to accept the reality of the loss, to process the associated pain, to adjust to a world without the deceased, and this is one we're really interested in for this project, to find an enduring connection with the deceased in the midst of embarking on a new life. So what kind of current approaches are there to tackling prolonged grief disorder? Well, one is pharmacological treatment, so any kind of like medication. The pros of this approach is that it is effective at reducing symptoms because pharmacological treatments typically target depression symptoms. However, it doesn't target the underlying cause. It doesn't actually help the patient accomplish those 4 grief tasks. There's a risk of dependence. As with a lot of pharmacological treatment, there's a risk that they will become chemically dependent upon their treatment. And possibly even the worst of these drawbacks is that pharmacological treatment can actually interfere with the neurological functions that are necessary for adaptation to loss. So while it's effective at reducing symptoms, it actually stops, worse than doing nothing, stops a person from being able to resolve their grief, adapt to the loss. So another approach is psychological interventions. These are also an effective form of treatment. They relieve symptoms like pharmacological, but on top of that, they actually target the underlying cause. A psychologist or other mental health professional can help the patient to achieve these 4 grief tasks and help them genuinely resolve their grief. The drawback of this is that the demand simply outweighs the supply considerably. So 10% of patients have been waiting over a year for treatment, and over 50% of patients have been waiting over 3 months. And it's across mental health counseling services, these figures. So these professionals, are being sought after to resolve so many people's mental health problems. And mental health is, I think mental health issues are so prevalent that I believe it's been officially declared a mental health epidemic that's going on. So obviously there's just not enough to cater for all these people. So there's another kind of service that people suffering, particularly from prolonged grief disorder, can go to, and these are mediums, psychic mediums. These are performers who use cold reading skills to infer communication with the deceased. So by this, I mean we're not claiming these people genuinely do have a connection with the dead, but they use these mentalism techniques to act as if they do. But this purported line of communication does allow patients to resolve their grief if they, similar to pharmacological treatment being, if you use a placebo, if it's kind of that power of mind thing where if you genuinely believe that the medium has the communication with the deceased, or you allow yourself to believe it just for the session, you can use that purported line of communication to resolve whatever grief issues you have and achieve those tasks. However, there are some drawbacks. So mediums have to charge a living wage for their services. This is what they do for a living. This is their time being taken up. So they have to charge a living wage. So this renders them inaccessible to many people just from a monetary basis. And also because these mediums are human beings, they're unable to deliver readings to multiple clients at once or at all hours of the day, meaning sometimes they need to eat and sleep and go about their other daily business. So we've seen that pharmacological treatment can have a lot of significant drawbacks, and we've seen that both psychological treatment and mediums, their main drawback is their inaccessibility, either for money or time or just demand. So what about chatbots? Some of you may actually be asking me, what are chatbots? I'll give you a brief history on chatbots. Chatbots from 1966 to 2020 and hopefully onwards. When we're talking about chatbots, we're actually talking about a wide range of things. So chatbots are also conversational AI, conversational artificial intelligence, artificial conversational entities, people call them. And these range from simple rules-based chatbots like Eliza from 1966 to complex neural network architectures using things like GPT-3. So we have a wide range of technologies involved. And many of you, this is kind of AI, so science fiction still often paints AI as this malevolent force, and especially with chatbots, maybe some of you are thinking of HAL or something. But chatbots are improving to be an increasingly useful tool. For example, it's been predicted that in 2020, 30% of all web searches were being conducted without a screen, i.e. via a voice interface like Alexa or Siri. So there's people asking for the news, the weather, definitions of words, facts, maybe settling a debate in the room and ask the Home Assistant. But this is an example of a chatbot. It's a voice interface, but it's essentially a chatbot. So you may all like to know about the accessibility of chatbots. Are they accessible? Well, in different ways, yes. So some of them are accessible to the deaf by default. So these are text-based input-outputs that don't use sound, voice at all. So like Facebook Messenger bots, if you ever gone into a business's Facebook page and a Messenger window pops up with automated script that answers your questions, these are text-based input-output. You don't need any kind of voice for that, or being able to hear any kind of audio output. And you can adapt this for blindness as well. So you could have speech-to-text software for your input. So into the chat window as they're typing up. If you don't have like a Braille keyboard or aren't familiar with the layout of your keyboard, you could speak into the software and it transcribes an input. Alternatively, so additionally to that output, you could use a screen reader, but these aren't always compatible with the output formats. Sometimes on a window, screen readers will interpret a chat window as just chat window, won't actually be able to read the text inside, so that's something that needs to be addressed. And As for some chatbots are just accessible to the blind by default, so voice-based input-output type bots like Home Assistants, Alexa, Siri, like mobile assistants. These don't require any kind of sightedness or text. They just use your voice. And these could also be adapted for deafness as well. Generally, these will have text-based companion apps or functionality. I know, like on your Siri, you can hold down and type instead. And Home Assistants generally have a companion app that goes along with it. But these are fiddlier than the conventional usage. It's harder, it is harder to open up an app and type it out rather than just say it in a room. And this could possibly be addressed, possibly like having a camera that waits for a activation sign. I know there are people doing lots of computer vision research on detecting sign language. So maybe something like when you say, "Hey Alexa," instead maybe a sign that does the same thing and then activates the system could be an alternative approach. I'm sorry if I've been activating anyone's Home Assistants while I've been doing this presentation. And also for translation, so people who I know computing generally does have a strong bias towards English language, but we can incorporate translation into our models using machine translation techniques. So think like Google Translate uses these machine translation techniques to convert words from one language into vectors that then we get the same vectors and put them into the output in a different language. And we could add this again on end to end for our chatbot to utilize the same model, but just before and after translate the inputs and outputs. There are some ongoing accessibility issues in chatbots. Accents are one. So users with strong regional accents, like Scottish accents for one in particular, they can struggle with voice interface chatbots, particularly if the training data set didn't include their accent. So what I'm talking about there, with these deep learning models, they have to use this like tons and tons of data. But if there were no examples of Scottish accents, this machine learning model has never seen a Scottish accent, or never heard a Scottish accent, so it doesn't know what to do with it. It can't interpret it as easily. And spelling, users with dyslexia can struggle with text interface chatbots because chatbots generally aren't too computers generally aren't too bright. They can't interpret things the way humans can, so it needs to be spelled just right, unless you incorporate some kind of spell checking stage before doing the processing. So current approach. So I'm not the first person to think of using chatbots to resolve prolonged grief disorder. Grief bots have been around for a few years now. And when I talk about grief bots, I'm talking about a chatbot specifically designed to help with grief, and inferred by the name. The benefits of these, so these can help to resolve grief through conversation by the idea is recreating the deceased person. Like a medium purports to have that line of communication, so bring the deceased into the room with you. This kind of recreates their personality in some way and allows you to essentially talk to the person who you've lost and resolve whatever grief issues you may have. There are two main methods of creating these. One is training your chatbot model on personal messaging data, like extracting data from Facebook or WhatsApp or something, other messaging services. I don't know if I can name, but an example, I know Roman bot by Eugenia Guda made that one. And there's also recording query response pairs prior to the deceased passing. So this works if you know someone's going to pass on soon. You might schedule this kind of interview with them, and you record a series of query response pairs. Basically have a conversation, interview with them, a conversation, and later on, these can form the basis of a kind of very simple rules-based chatbot, which matches input similarity to a recorded input, and then outputs their recorded response. There's some problems with these. There are some inherent problems. So messaging, so the first method where we train on personal messaging data, the messaging data may be non-existent, sparse or private. So this means they may have never used the messaging service. You go to download this data from the service and they may just have never had the service, or may have had the service but never used the messaging. Or that it may be sparse, so they may have used the service but not really enough to train a full conversational model. Deep learning typically requires vast amounts of data, and if the person only exchanged a handful of very short messages with people, it won't be enough. Or they may wish that all their messaging data be kept private in the event of their passing. We have to respect the deceased's wishes, so we can't use that data. The other method, recording query response pairs prior to the deceased passing, obviously the inherent problem there is that you have to have preempted the deceased passing, and you have to have been aware that this service was available in order to consider it, to use it. So we propose a new griefbot method. This one will automate the cold reading process. So cold readers, they're different. We talk about cold reading as opposed to hot reading because the cold infers there's no knowledge going in. The psychic medium is just approaching from a kind of blank slate and going to apply the same techniques every time to each client and produce what seems like a personalized output. It seems like they genuinely have a connection with your deceased loved one. So this doesn't require personal messaging data if it manages to use the techniques correctly. And it doesn't require the deceased deaths to be preempted. We don't need anything pre-prepared going in about the deceased. Because it's a chatbot, because we're automating it, we don't need to charge a living wage to each patient. It can deliver readings simultaneously in 24/7. This chatbot can be working around the clock, delivering readings to hundreds, thousands of users, however many the servers will allow, and so it's accessible to everyone. So we're making a chatbot. We need some resources. So we're going to use some data. This is our main resource. One example, one bit of data we use is the archive of medium and cold reader data, which is the acronym for this is AURA, which I've highlighted the corresponding letters in bold there. It's one of those acronyms where you're like, really? But anyway, that's the AURA data set. So these are transcripts of psychic medium readings conducted live over the phone. I think these were all conducted on the Larry King show. So this was over the radio, and the readings were done over the phone. So there was no visual data as well, which is really important for us because our chatbot isn't going to have necessarily a camera fixed to it. It's just using whatever this voice or text interface. So it's important that the mediums in the data weren't using visual information because our chatbot won't have it. So this is in total 3,908 lines of text before any major cleaning, although I do a bit of selection and just extracting the relevant pieces of text from the data set, that correspond to the actual psychic readings from a subjective viewpoint. And we also use later on the Cornell movie dialogues corpus. Many people in natural language processing are familiar with this data set. These are conversations extracted from movie scripts from a vast array of genres. In fact, it's 220,579 conversational exchanges across 617 different movies. Okay. So we've got our data. Now we need to apply the data. So our methods, we first use association rule analysis. This is quite an old method. So we use the a priori algorithm over the AURA dataset, just the AURA dataset by itself. And we are using this to create a rules-based chatbot. This is one of the early ones, like from kind of 1966. Like I mentioned, but rules-based chatbots are still often used today for many applications. So this will just have fixed kind of input-output pairs, maybe with allowing for wildcard characters and words. There'll be some flexibility on the inputs, but there won't be any flexibility in outputs. The outputs have to be very set. That's why we use full-length reader responses on our right-hand side of our rules, and the left-hand side, any kind of caller n-gram. So these can be single words, pairs of words, trio of words, etc. So we create a document term matrix with a binary frequency for this, and then we apply the a priori algorithm. We set our parameters, so our minimum count, our minimum support or count has to occur at least twice the rule in our data set. Confidence 50%, so the right hand side, for a rule to be output, we have to have the confidence in the rule of 50%, meaning that the if the left hand side of the rule, then it's at least 50% likely to be the right hand side of the rule, if that makes sense. And the minimum lift, or both way dependence on both left hand side and right hand side to each other has to be 1. So they at least have to have as if they were independent rather than inversely dependent. So these are fairly low kind of thresholds we're talking about. But even though they're fairly low, we only get 7 rules that meet our minimum parameters. I've shown them here, but I'll just describe them very quickly. So we've got like the left-hand side. If the input, the caller said saw him, the output would be I saw him, and a few variations of that. Left-hand, if the input said grandmother, just the output says yes. If the caller said good evening, Sylvia, I think Sylvia was one of the mediums, the output says yes. So these aren't very good. These are insufficient for mediumship or even just general conversational ability. So we have to be a bit more advanced in our approach to building a chatbot. So I'm instead going to use deep learning techniques. These are more recent, and so when we're talking about deep learning, we're talking about artificial neural networks. These are bio-inspired machine learning model. I mean, artificial neural networks. Neural networks were inspired by the brain. How do neural networks in the brain work? But these are densely connected layers of nodes. Although in this instance, we're not talking too deep in terms of number of layers. We have our input layer, which takes word indexes, and then an embedding layer which converts words into word vectors to capture meaning and relationship between words, and then the sort of processing. And that's sort of mirrored in the decoder. So we've got artificial neural networks, and recurrent neural networks are taking the artificial neural network concept, and we're kind of unfolding it through time. So we feed our tokens sequentially, because otherwise if we just input the sentence as a sentence, like all in one, we lose the word order. And word order is important. I mean, the dog bit the man is quite different in meaning to the man bit the dog, right? So we have to do these in order, and thus we get kind of encoded a kind of well, it preserves the sequential properties basically. And sequence to sequence is taking the RNN and saying, okay, let's take one RNN, put it to another. We'll encode our sequence in here, and then we'll take the last hidden state of that encoder and make it the initial hidden state of our decoder, and we'll output step by step. Now we'll decode. This is often used in machine translations. So we encode, say, an English sentence word by word, and then decode and output the French translation word by word. And also we have things like long short-term memory. There's also gated recurrent units do a similar thing. These incorporate memory gates, which kind of act as like a highway connection across your sequence, and these preserve information, avoiding the vanishing gradient problem, which is a common problem in these recurrent neural network architectures. So we make sure we keep the information. Like if I have a long input sentence that mentions a particular person at the start, and then I say he at the end, who's the he I'm referring to. If my model in training has lost the information from the start, it doesn't know, but if I incorporate a long short-term memory, it will remember who I'm talking about. So we train a sequence-to-sequence long short-term memory model. We use Aura and Cornell movie dialogues corpus. We remove exchanges with utterances longer than 25 characters long. This is partly to help with our efficiency, but also chatbots generally struggle with longer inputs and outputs. So anytime there's an exchange where either the input or the output is longer than 25 characters long, we remove it. For the Cornell dataset, we also removed unique exchanges because there's so much data, we can afford to do this. Unique exchanges tend to have unique context, so we don't want the chatbot to necessarily learn these right now because it might be talking about something that was only unique in that one, only applicable in that one scenario from the dataset. So we train this for 200 epochs, so this model goes back and working out this error, making tweaks about 200 times. We use a batch size of 4, so we take 4 exchanges at a time for each, and then until we've run out of the data set, then do it again, so 200 times. At the end of all this, these are results. So these I've just taken some screenshots of conversations with my psychic medium cold reading chatbot. So we can see it exhibits conversational ability in the example where I've said, I say hello, the bot says hello, I say are you okay, and the bot says I think so. This is a reasonable conversation, right? This is okay. Nothing seems too strange here. We can also see in the other 2 examples, the other 2 results, the chatbot kind of adopts the role of a medium. If I said to it, like, oh, I lost my father, it says, I know he's right. I mean, that's a bit strange, but it's kind of like interpretable. Can you hear my father? It does say yeah, which is a bit strange, but yeah, it's generally a good response. Is he okay? Yes, that's good. That's reassuring. Is he proud of me? Yes, good, reassuring. It's responding appropriately. Same for grandmother. So grandmother died. Yes. Can you hear her? Yes. Well, yeah. Sorry. It says, what does my grandmother say? Hello. That's brilliant. That's just what you want to hear. Can you tell her I say hello? Okay, perfect. Because if it just outright refused, that would be unfortunate. But that's perfect. That's exactly the kind of scenario we want. It's not very complex. It's not exactly performing Barnum statements, rainbow statements, or anything, which are some cold reading techniques. But it's responding appropriately is the main thing at this point. However, it's not all perfect. The chatbot can produce insensitive responses. In this instance, I asked it, what's heaven like? Which is a perfectly reasonable question to ask a cold reader or psychic medium. It said nothing. When I said, what's hell like? It said you, which was flattering. So sometimes, and also sometimes it's just entirely incomprehensible. I said, how are you? It just said, I. If I said, is my dad watching me? It said, is it? I say, are there any messages for me? It said, is I this okay? So this just doesn't even make any sense. Which is disappointing. So there's further work we can do. We can incorporate multi-turn context. So far our chatbot is just producing its output based on the last input it received. It's not taking into context the rest of the conversation. So if we can incorporate a kind of multi-turn context ability to our chatbot, it will be able to remember more and thus might make more sense. And we might be able to have more complex conversations with it. Also, data scarcity. For a deep learning model, this chatbot uses a relatively small volume of data. I know it's somewhere in the hundreds, I think. I can't remember the exact number of rows off the top of my head. Sorry, I used to. But yeah, it's not a lot of data really. But if we incorporate some multi-turn context, we could use those examples in the data set which have unique context which we removed before. So that would give us more data as well. So solving the multi-turn context problem could give us more data. That's my entire presentation. I'm sorry if it's dragged on a bit. Thank you for your time. Are there any questions?